afternoon to all and welcome to the DNA Café. For the people who attended Curiosity today this afternoon, I hope you had an enjoyable afternoon, but let's now have some after drinks in the DNA Café, the Data and Analytics Café central around data and analytics. And we're going to talk about amazing and state-of-the-art evolutions on the field of data and analytics. And when I talk about amazing and state-of-the-art, I really mean amazing and state-of-the-art. And my two guests of today, they know everything about AI and about using specific AI techniques for generating synthetic data. My two guests of today are people from Syntho. Welcome, Wim Kees Jansen and Marijn Vonk.
Thanks for having us.
Please, Wim Kees, join me at the bar.
Thanks.
So, Wim Kees, you and Marijn, you're both founders of Syntho. Now, I can imagine that many people haven't heard yet of Syntho. So, what is Syntho about? Can you talk us a little bit about what Syntho is doing?
Yes, sure. So Syntho is a data technology startup with a mission really to open a data economy where we can use and share our data freely. And we are a software development company, and with our expertise in AI-generated synthetic data. And that's, of course, what we're here for. Here you see our team. We are located in Amsterdam. And as mentioned, we develop software and with a mission to really provide organizations with easy and fast access to high-quality data via synthetic data generation. And we have strong collaboration partners. So we have Tin Capital. It's a venture capital firm focused on cybersecurity tech. We are part of the IBM HyperProtect Accelerator program. It's a program focused on cybersecurity software solutions. And finally, NVIDIA, the Inception program, focusing on AI startups. And with our proposition, we recently won the Philips Innovation Award, so really proud of that.
Congratulations!
And, thanks. And of course, here today to really deep dive together on the value of synthetic data and typically also on the questions about it.
So I understand that if you don't have the data, you have to come to Syntho because Syntho can create synthetic data. Now, for the people watching us at home, if you have any questions for Wim Kees or for Marijn from Syntho, just ask them in the chat because at the end of the session we have a Q&A session, and I'm sure that Wim Kees and Marijn are more than happy to answer all your urgent questions. Now, Wim Kees, when I read online the day of today, I see that there is a huge overload of data. We are practically drowning into data. Data is captured everywhere, and yet you and your company, you have decided, well, let's create even more data. Now, is there a need for synthetic data today?
Yeah, I think interesting indeed. It sounds like a paradox, but I think one of the challenges that many organizations face is actually doing something with the data. And that means getting access to the data, share the data, both internally and externally. And I think we see major challenges around getting access to the data. And these challenges are the challenges that we aim to solve with Syntho.
Okay, so synthetic data really helps in analyzing sensitive data, right?
Exactly. Yeah.
Okay. So does that mean that Syntho basically anonymizes data, or what do you mean exactly by synthesizing data?
Yeah, I think we have basically three measures. So you can use, of course, your original data, but sometimes you cannot use it. And then one other alternative is to anonymize it. Now, before we dive into synthetic data, which is something different, I think it's good to really deep dive with the start, and that's anonymizing. Mm-hmm. Because, of course, and this is the challenge that we want to overcome in this case with synthetic data, but maybe also with anonymization. You want to make sure that you can innovate with data, and on the other hand, preserve the privacy of your customers, patients, or individuals. And one solution is applying anonymization. Mm-hmm. And to give you a couple of examples, you can generalize the data. So someone is 27 years old, and you're going to place them in buckets between 25 and 30 years old. You can apply suppression or wiping. You have an identifier, an email address, and you simply delete it from your data set. A third one, pseudonymization. You have an identifier, and you replace it by a code or a hash. And finally, row and column shuffling. So first you have aligned data, and then you shuffle it around, and you have shuffled data. So these are some examples, and I think really what you see here in the examples is they basically manipulate the data in order to hinder tracing back individuals. And yeah, that comes with a couple of disadvantages. So first, it stays the original data set. It's a manipulated version, but you always have a privacy risk, and especially with all the technologies and open data sets. Yeah, that is a risk. And to really prevent that, you can apply those techniques more and more and more. But when doing so, you basically destroy your data, and that's not what you want for analytical purposes, because then you run into the garbage in is garbage out principle. And finally, as you can see in these examples, applying classic anonymization techniques work different for each data type and for each data set. So that's really a non-scalable solution, and typically you have a lot of discussions about how to apply them, which technology to use. And yeah, typically that boils down to this trade-off between privacy protection and data utility. So you can apply those techniques and then you partly destroy the data, but you always have a privacy risk. And to overcome that, you can apply those techniques more, and you can apply those techniques more till you basically end up in the left side where you destroyed your data. And that's not what you want. And the difficulty here is becoming somewhere on this line is challenging. And that's typically where you have all the discussions about how to apply those techniques in practice. So that's in a snippet about classic anonymization techniques. So you will always have the privacy risk, you destroy your data, and it is not really scalable. Then introducing synthetic data, because that's where we're here for, of course. I always like to do that via these illustrations. So yeah, the question to you, Veronique, which of these do you think is fake?
It's a tough one because they all look very real, but if I have to choose one of those three, I would say A, and the reason is very simple, because I think she looks a little bit too much to Meghan Markle, but maybe I'm wrong. I don't know, tell me.
Yeah, let's take a look. I'm also happy to see the reactions in the chat, but to give you the answer, they are all fake. So you were right
so I was
in this
right,
case,
yeah.
But yeah, it was always a price, as we say it. So these are images not captured by a photo camera. These are images generated by a computer algorithm. And that's basically the essence of synthetic data. So original data is generated by your source, interactions with client, patients, individuals. And synthetic data is generated by a computer algorithm.
Wow, impressive.
Now, we like to illustrate this with images to explain the concept. But what we do is we apply this on structured data. So data formatted in tables containing rows and columns similar as you see in your Excel sheet, your databases, etc. And we apply the same concept. So you have your original data set. We have a computer algorithm. That's what we call the Syntho engine. It is trained on the original data to learn all the statistical patterns, relationships of that data set. And thereafter, it's able to reproduce synthetic data. So synthetic data is completely new generated data points. And we apply AI to model those new data points in such a way that we preserve the statistics, patterns, and relationship of that original data set to such an extent that you can actually do analysis on the synthetic data. And that's why we're here for, because is that true? And what if we use synthetic data for analytical purposes?
So if I correctly understand, synthetic data is something completely different than anonymized data. It's old school anonymized data, right? But the synthetic data will solve many disadvantages that you have with data anonymization. Now, I love to listen to this, but honestly, I'm a little bit curious about some results on synthetic data. And for that, we have here as our SAS expert, Edwin van Une. Edwin, you are a customer advisor at SAS. And let's be honest, you're the true expert in data analysis in SAS. Now, Edwin, you had the chance to play a little bit with synthetic data. And I think me and also the audience is more than curious to listen to you and to see what you have discovered in the data. So please join me here at the table.
Let's go ahead. Okay, so...
Yeah, but maybe first, before you start explaining your findings, I'm quite sure that everybody is really interested in the findings, but maybe first, Edwin, why is synthetic data so important, so interesting for you, but also for SAS, for example, for a company?
Yes, synthetic is very interesting for me as a customer advisor, also for SAS, because, well, I come across a lot of situations at customers, and I work in the area of machine learning, AI, optimizations, and these kind of things. And often I want to show the capabilities of machine learning, and I need data. Mm-hmm. And sometimes I don't have the data to show these capabilities. So I think there are two main applications of synthetic data. And first, we have the situation that I want to show the capabilities for that specific use case in that industry, mm-hmm. But I don't have the data. I can generate some dummy data, mm-hmm. but I want to have really the data that's very similar than the real data. So in that case, yeah, synthetic data would be very, 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 very useful. For example, when you want to train a computer vision model on detecting objects in the images. I have a couple of images, but I want to have a lot of images. Mm-hmm. So I can generate these additional images from the original images. And the other application, I think, is we also see that I come to customers and they ask me to build models, predictive models, for example, on data. But I'm not allowed to see the data. I'm not allowed to use the data because it's because of privacy regulations. I'm not allowed to use it. So in that case, we could say, well, can you transfer that data from original data into synthetic data? And that's exactly what we did together with Syntho. And I wanted to test it because it's very interesting. But when I build predictive models, is the predictive power the same?
Yeah, yeah.
Is the information in the data set, is it preserved, yes or no?
Okay,
and that was finally the test.
And you had the chance, right, to work with synthetic data, to investigate the results of analytical models on synthetic data. Now, I'm curious, tell me more. What are your findings?
Yeah, we can have a look at the findings. Do you want to talk about the output of what you delivered to me as first, before I show the output?
Yeah, I think that's definitely interesting. So basically, this is a question that we receive frequently. So what we typically do is for every synthetic data set that we generate is deliver a data quality report. And that includes various statistics like distributions, correlations, and multivariate distributions to really indicate the data quality where we compare the original data with the synthetic data. So I think it will be interesting to go through that and then, of course, dive into the complex analytics. So I think what we see here is the distributions. So we see it in gray, you see the original data, and in blue, you see the synthetic data. And we can actually go to the next slide to zoom in on two of these graphs. So on the left side, you see one categorical value, in this case, the churn. And there you really see that when we compare the original data with the synthetic data, that the results are really similar. So the same amount of persons in the data set that churned and didn't churn. And then to the second illustration, there we see the age, and there we also see that the lines really overlap when we compare the original data with the synthetic data. Then when we go to the correlations, we have a correlation matrix where we compare on the left side the original data and on the right side the synthetic data. Normally a correlation is between -1 and +1, but for illustrative purposes we indicated it with color intensity to really compare the patterns, and also here we see similar results. And then to the final part of our quality report, the multivariate distributions. There we combine the combination of variables and the frequency of those combinations in the data set. And even there we see similar results. So for example, on the right side, you see the combination of clients that churn in a certain segment. Even there we see that the patterns are similar. And this is basically the highlight of our data quality report. But that's of course from our side. And I think the interesting part is, of course, okay, what if we do advanced analytics on that data? And that's of course the case that we did with this use case.
Yeah. So the input data is similar to the original data.
Yeah, it's very, very similar. It's not exactly the same. It's similar. It's not the same.
Yeah. But we would assume then that the results on the original data and the synthetic data are also similar.
Comparable. Yeah.
Is that true, Edwin?
Yes and no. We will see. Yeah. So I used this diagram to show you what we actually did. So I sent an original data set to Syntho and they synthesized this data set. But the question was also, well, let's compare it also to anonymization, because we already talked about anonymization. We said, well, you lose a lot of information in that anonymization data set. Well, is it really true? So what we did, I had this data set from telecommunications industry, 56,000 people. People have left the company, so there's churn. It's a churn case. That's the target for my modeling. A lot of inputs, 128 inputs, potential features for the models. So it was a great data set to build some analytical models. And we gave it to Syntho, and they, of course, synthesized the data set, but also we tried some anonymization techniques. And then when I received both data sets, I started modeling using SAS. So I built a churn model on the original data set, and actually a couple of models. I used classical regression techniques, classical decision trees, but also more sophisticated techniques, neural networks, gradient boosting, random forest, these kind of techniques. And I used the standard options of SAS because I didn't want to tweak the model too much because then you don't really can compare it. So the standard options of SAS, just use SAS, build some models and look at the results. And the results were very, very promising, not for anonymization, but for synthetic data. When you use it for, you look at the results for anonymization, we look at, and for the non-machine learning experts in the audience, we look at the area under the curve. And the curve, that is the ROC curve, and that's, well, telling you something about what are the true positives and the true negatives in your data. Is the accuracy of the model okay? And when you compare it in the original data with the anonymized data, we see that on the original data, the area under the curve is 0.8. And on anonymized data, it's 0.6. And the maximum would be 1. An optimal model would have 1. So 0.8 is rather good. But 0.6, well, a random model should already have a half, 0.5. So we can't really use that anonymized model because you lose a lot of information, a lot of predictive power. But then the question is, what about synthetic data? So the next step, we did the same. We sent that data to Syntho AI. We have the synthetic data set. We built some models, the same algorithms, the regression models, neural networks, gradient boosting, etc. And now, of course, on the original data set, still we have the 0.8 area under the curve. But also on the synthetic data, now we have 0.8 under the curve. So it's very similar, not exactly the same. In fact, it was a little bit better, but that's more or less the variability. Yeah? So the data is not exactly the same, but a little different. So it's very promising. We're very happy about this. But you would argue that, well, is it really a good test? Because, well, this is actually the test set. Eh? I used the test set of both the original data and the synthesized data. So actually, I want to use that model on the original data. So next step, finally, I used a holdout data set.
Okay.
So there was 10% of the data I didn't send to Syntho. So I used that holdout data set to test the model on synthetic data on that original 10% original data. And then also in this case, the predictive power was preserved. We could have the same accuracy on this holdout data set. So it's really promising.
Yeah, so they can underestimate you, Edwin. You always have something in the back.
Yeah,
now,
yeah.
When I see those results, am I right to state that we don't have to worry anymore about the accuracy of our predictions when we use synthetic data?
Yes, well, I'm an analytical guy, so I never worry about analytics, of course. But,
of course.
Okay. Yes, the answer to this great question. The answer is a little bit yes and no. And maybe it's good to explain with the next picture. We saw the accuracy of the models on synthetic data is similar, almost the same as on original data. It's for random forest, for regression models. In this case, for a decision tree, it was not the case because the data was too complex to create a nice decision tree. But for the other models, the more complex models, it's really the same. So indeed, we don't have to worry about the accuracy of the models on synthetic data. But yes, we have to worry a little bit because when we actually use this model in production, because that's what we want to do, we want to use that model in a production setting, we have to score, what we call as data scientists, score that model on data of new customers. Will that customer going to churn, yes or no? And in this picture, I compared the probabilities, the outcome of the models from the synthetic and the original dataset. And we see when you compare those two, there will be some, when you use that synthetic model on the original data, there will be some overestimated customers and also some underestimated churn customers. So for an individual customer, there's a difference. You would think he's going to churn when you use it on synthetic data, but actually when you use it on original data, it's not going to churn. So in this case, when you really want to have the same outcome for your customer, you want to explain the outcome to the organization or to the customers, then my recommendation would be that, okay, after developing your models on synthetic data, then retrain the model on the original data, and then use that model in production. And that could be a solution for this case.
No. So synthetic data is luckily not replacing data scientists.
No, definitely not. Still having a job.
So are there any final conclusions that you want to make and share with the audience?
Yeah, the final conclusion for me was, yes, we can really use this approach. Really, you can see it, the importance of variables, what features do I need for modeling. You can create your pipelines on synthetic data. You can see what algorithms you can use. The outcome, the accuracy is the same. And we saw that, well, scoring individual customer, well, you have to worry a little bit about that. And the final conclusion for me, there are some use cases that, well, maybe that's a problem. So maybe maybe in public sector, when you really have to explain what you're doing, or in banking, or in healthcare, patient data, really have to explain, well, we don't think the surgery is for you, we don't send you for a new surgery because of, you can't say, yeah, your synthetic data is saying, that's ridiculous, of course. In that case, you really need to model the original data. And maybe also for example, when you're looking for outliers, because when you generate the synthetic data, you don't want to have the outliers in your data. You want to get rid of the outliers because privacy regulation, maybe you can come to that individual customer when you look at the outliers. Yeah. But for example, for fraud, you want to have that's important, the outliers. Yeah. So in these kind of circumstances, well, it's not useful.
Okay, but anyway, thanks for sharing your experience with the data, with synthetic data. And thank you, Edwin, for all your expertise. Now, I have heard the word sensitive data, privacy data a couple of times. And of course, that brings us to a very specific topic. What about the privacy considerations that are attached with synthetic data? And what does it exactly mean when we preserve this privacy? Now, we have the pleasure to have Rijn Mertens here today. Rijn, you're the customer advisory manager at SAS, and we have to say that you're the expert in terms of data privacy and all legal and ethical considerations that come together with data. Mm-hmm. Now, Rijn, do you mind sharing with us a little bit what the privacy perspective is of synthetic data?
No, of course.
Please join me here.
Yes. What you see when you talk about synthetic data, you could say that, why do I have privacy issues at all? Because the synthetic data is not related to an individual anymore, right? However, how to get to that synthetic data? So there are a few questions to consider. There are actually 3 crucial questions you have to keep in mind. First, are you allowed to use that data for your use case at all? And then, when you use that data so in other words, does it fall under the law, under the legislation, that data? And then you have to think about, okay, how to make that synthetic data? How to get that to a service provider, for instance. Or, when it is synthetic data, how is it going to be shared afterwards? Are there any regulations for that? And if we remember, if we look back at the GDPR legislation, in Dutch the AVG, we are all familiar with since 25th of May 2018, there are some so-called lawfulness of processing rules. In other words, for what kind of reasons am I allowed as an organization to process personal data? Well, And we know those. We probably remember. Do we have consent of the individual? That's not the first thing you want to use normally because that's quite complex. Do we have a contract? Do we need to process that data because of a contract? Is there another legal requirement, a vital interest? For instance, when you walk out in the streets and you see someone collapsing, then it is allowed to take his wallet out to see who he is and to call an ambulance. That is allowed. That's a vital interest. It's personal data, but you are allowed to do that. Is it the public interest? Or finally, and that's mostly used, I would say, in my practice, is a legitimate interest. So then you are going to balance the privacy impact of the individual versus the interest of the company. I need to process that personal data to do our job in our company. And of course, you need to do things for that. You need to do an assessment. You need to balance that interest. Probably there's also a data processing agreement needed for that, right? Or you need the records of processing, of course. You need, as an organization, to register that activity. But if you have done that according to the law, you are allowed to use that data for the purpose you want to do, and you have taken all the steps needed within the law. In this case, GDPR. Of course, there are other laws as well, but I'm focusing on GDPR. What I see is very interesting because you can apply more easily privacy by design. When I ask someone from the team, not Edwin of course, but a young, just graduated person, and say, well, it's nice to do data science, but privacy by design, right? And then privacy by design, I don't know what data I have to use. Give me everything, right? And that's sometimes challenging, how to balance that. So you could say data minimization based on synthetic data. I already get rid of a lot of columns I do not need at all in the rest of the process. You can use that on synthetic data. But also there are less people who need to access the real data, the real personal information. What we have seen over the years at organizations is that a lot of data scientists and business analysts were able to get data from everywhere, ending up on a server with thousands of data sets. And then GDPR came along, and then the security officer said, or the privacy officer, okay, where is all that data, right? And then if we can prevent that, that would be beneficial as well. But also less chance of data breaches, because when data is shared and it is synthetic data, it's not personal data anymore. So when someone sends it to the outside world or on the website, it's not personal data. So, and of course, finally, faster time to value, because there's a lot of paperwork, a lot of things to do, what Edwin said, to get access to data. And when you can have access to synthetic data, that will speed up the whole process. Yep.
So the good old times of having our data on our local computer, that's over, but luckily we have Syntho for creating synthetic data to enable it a little bit more.
That's how it is.
Okay, perfect. Yeah. So that's great to hear that the legal considerations are solved with using synthetic data. And coming back to you guys, I mean, I only hear positive things. Synthetic data works better than anonymized data. The results of Edwin are extremely promising. It helps to solve many legal considerations that companies are struggling with. Plus, you can say that you're synthesizing data. That's just rock and roll, right? So, but now you have launched Syntho. It's a rather new company, launched in 2020, right? And then COVID came. Now, did you already have the chance to prove the value of synthetic data in practice? Do you already have some use cases to share with us? Yeah, I see you're nodding, so tell me.
Yeah, exactly. So we have many successful use cases in place. And I think the challenge is indeed what Edwin mentioned. In some use cases, it does not add value. What I always say is that if you want to send invoices to your customers, do that with the original data, because if you send them to the synthetic data, you probably again
they don't know what they're paying for.
They probably will not pay the invoice. So the question is, when does synthetic data add value? And today I want to discuss 3 key use cases that we see at Syntho for synthetic data. And the first one is that we showed today already, that is using synthetic data for modeling and advanced analytics. The second one is using synthetic data as test data for software development. And the third one is using synthetic data for product demos. So use synthetic data as demo data. So I think it will be great to go through those three use cases and start with the first one. And use synthetic data for model development. I think in the current situation, we see many organizations struggle with having a strong foundation to get easy access to high quality data. And that's basically where we started with today. And the key challenges are it takes weeks or months to get access to data due to regulations, internal processes, data silos. And the second aspect is that classic anonymization techniques destroy your data, making the data not suitable anymore for analytical purposes, as was demonstrated today during Edwin's assessment. And the third one is that those classic anonymization techniques, they work different on each data set and for each data type. So they're not scalable, it's a lot of manual work, and you typically have a lot of discussions which technique to use for which data set. And since data set typically change every minute, real-time data, you constantly have to adjust those techniques. So that boils down to our solution, use synthetic data to develop models upon. And we can do that in three forms. So we can do ad hoc data synthesization, we can establish a synthetic data warehouse, or we can establish a synthetic data sandbox environment. And with that, you can train, test, and develop your models on the synthetic data. And as was being illustrated by Edwin, of course, thereafter you could score those developed models on the original data. And the value here is really that instead of taking the data to your development team to develop models, you can develop the models and bring the model to your data. And the value really there is that you are able to minimize the use of data without hindering your developers. You can unlock personal data that was restricted due to regulations. You have a solution that works easy and fast. And of course, a scalable solution that can work on small databases, but also on large databases and with multi-tables. So that's the first use case. So using synthetic data for model development. Then when we go to the second use case, it's about using synthetic data as test data for software development. It's slightly different because with software testing, you typically you need test data to develop your software upon. Production data seems obvious, but unfortunately, it's not allowed. And then the alternatives, they introduce also key challenges. And with test environment, it's really about having those alternatives, you lose your business logic, your business rules, and your referential integrity, which are essential to test, do cadence test, chain testing. So that's the first one. Then, of course, specifically for testing, you want to actually optimize your data for testing purposes. So typically, you want to test on edge cases, situations that do not happen frequently, and you want to generate more of those subsets of the data. And finally, sometimes you do not have data yet. And then you want to generate completely new data. For example, if you develop a feature, then you first need the data to develop the feature upon. So that's what we can solve with Syntho. So basically, we can generate synthetic test data so that one can develop state-of-the-art software solutions by high-quality test data. And the value here is really that you can, of course, have high-quality test data with preserved business logic and referential integrity. But I think a second aspect, and that boils down to optimizing your data for testing purposes, is that you can generate more data, simulate data. So the first example that I gave is testing edge cases. You want to have more data of a certain subset, or you want to generate more new data because you do not have data yet. So you can really simulate data for your testing purposes. So those are solutions that we can provide for test data, and that really allows companies to improve overall testing, development, and delivery cycles, and release faster, deliver faster, prevent bugs in production, to, of course, have high-quality test data for state-of-the-art software solutions. So that's the second one, synthetic data for test data. And then the final one has synthetic data for demo purposes. Typically, we say seeing is believing. So you need to really make an astonishing product demo to really show your solution to your prospects. And then, of course, without data, you cannot do proper product demos. And here, yeah, client data seems obvious, but you do not want to use your client's data in your demos with prospects. So what are the alternatives? So yeah, the alternatives for demo data are that you can use your client data, but that's not allowed. But then you need to generate it by hand, and that of course takes time. And more importantly, it results in errors. So examples that we sometimes hear is that you get mails that are pregnant. That's not what you want in your demo, because then you're out. So what we can do is use synthetic demo for demo purposes. Really make sure that you have glossy data for the really perfect product demo. So of course we can generate errorless high quality data, but here we can also optimize your demo for demo purposes. So sometimes we receive the question, we are a Dutch company, we want to demo our product in Germany, we want to have German names. Or we are going to the heart department, we want to have more heart patients in the data. So that's what we can do with synthetic data generation. And really to optimize your data for demo purposes, and of course to really facilitate companies and make more sales, make better marketing materials, reduce barriers in product demos, and of course to make the best first impression. So yeah, that's the third use case. So yeah, in summary, the three use cases that we see is synthetic data for advanced analytics, model development. The second one is synthetic data for test data for software development. And the third one has synthetic data for demo purposes.
Now, how does it concretely work when we want to work together with you?
So as Syntho, we are a software development company. So we develop software for generating synthetic data with AI. And of course, that solution is available based on a license model. It's basically a subscription model, and we can easily deploy our model, and that's basically the second one, easy deploy a solution in the environment of the client, and that's of course one of the important aspects also being illustrated in the beginning, that you do not want to share the data to make synthetic data. So therefore, we can deploy easily within any environment. So we can deploy on-premise or in the private cloud environment of a client to make sure that the synthetic data generation process happens really within the safe environment of a client. So that's really about easy deploy. And the third one is easy connect. So we need to connect, for example, to databases, flat files, software applications, and we can easily connect our solution to those so that we can generate synthetic data on the place where you want it without sharing the actual data. So that's in short how it works. So a license model with easy deploy and easy connect.
Okay, so many options I hear.
Many options, but the bottom line is to make sure that we really work within the safe environment of the client. That's the bottom line indeed.
All right. Okay. Thank you for the nice introduction to synthetic data. I think it's very inspiring for all of us. And for the people at home, if you have some questions on synthetic data for Wim Kees or Marijn or one of our SAS experts, you can just post them in the chat, and we will be able to ask them directly to Wim Kees. And I think, Edwin, we already received some questions, right?
Yeah, certainly we did.
Okay.
Let's do this. I will ask the question, and if it's for you, stand up, take the mic, and address the audience. I received some questions about performance and large data sets. So does your solution works fast? Does it scale?
Yeah, sure. I can take that question. So performance on large data set. I think so. Edwin just showed a little bit of that, like that the performance on large data sets, does well in AI cases, for instance, and also in terms of scalability. So basically, if you want to deploy the model, it takes about 1 hour until you have a synthetic set generated, and I think that's also a big difference between data anonymization, for instance. Where it typically takes well, months, and I've actually seen clients, who were in the process of defining which data to take away, which techniques to apply, that it even took them a year to get their data anonymized. So I think that's a big difference with synthetic data.
Okay, thanks. Other question, I guess that's for Edwin. The modeling pipeline selects features as model inputs, right? In that case, does an algorithm on original data select the same inputs?
Okay, that's a nice question. Yes, as I understood correctly, I use, for example, a random forest on the synthetic data and a random forest on the original data. And does it select the same inputs? Well, what we saw in this, what I saw in my test is really the same. I looked at the variable importance. So how important is the variable for my model? And when I, for example, look at the top 10 of these variables, I see it's almost always more or less the same. Sometimes there's a variable, a different one in the top 10, because there's a correlation between the variables. For example, how many, it was telecommunications data, so how many data as a customer you used a couple of 3 months ago, or the last 3 months, or the last 6 months, or the last 9 months. And of course, that's very much correlated. So sometimes the 3 months value was selected by the model, and another model or on the original data, maybe the 6 months value was selected. But in fact, that's almost the same. And the data, to remember, it's not exactly the same. So it's not exactly the same data, the synthetic data. So there can be some differences.
Okay. Yeah, you can stay on
next
the
question
stage here. So another question from a fellow data scientist. So, well, we're going probably a little bit deeper. So some customers may get a different churn classification on the holdout data. How much? How many?
Yeah, how many? Yeah. It was about for the champion model. It was in this case the forest model. It was about, if I remember correctly, 5.9%. 5.9% of the customers, and of course it depends on the cutoff value. So when do you decide it's churn, yes or no? Is it at 50% or is it higher? So it depends. But in this case, it was about 5%. And the other models was about, 5 to 10%. And you could say that's a lot. But I also did some testing on the original data set. And then there you see also that when you switch from, for example, a gradient boosting to a random forest, both on the original data set, you also see that phenomenon, that some customers get another prediction, another classification. Because, the algorithm is a little bit different. The accuracy might be the same. In total, it might be the same percentage. But for an individual customer, it can depend on what algorithm is used. So, yeah.
Okay. One final for you, and then
okay, then
I'll let you go.
Okay.
Well, is synthetic data also useful for existing models?
Yeah, I think probably for the synthetic data depends on how you created the synthetic data. But you could test the existing models on the synthetic data and compare the accuracy of the model and the predictive power of the model compared to when you are trained on the synthetic data or a score on the synthetic data. So maybe to evaluate the quality of your current model, you definitely can use that. Yeah.
Great. Question for Syntho, I guess, or maybe Rijn. It's from Wanne. It's from a partner from you. Filers keepers. So if we reach the end of life of data, it's not about deletion, archive, or anonymization anymore. It's also about synthesizing. What's your view on that?
Should I
end of life data?
End of life data. Of course, according to different laws, data can be stored or can be archived for a certain period of time. If you have to do that, right? What you also see is that, for instance, within the GDPR, you can archive it and also to anonymize it. It's said there, or it's more called privacy enhancement techniques, PET, for research. But I think that synthetic data could help there, because then you preserve the quality of the data way better than for research, for have a long time series, for instance, of customer data without having the need to still keep the customer records, which you are not allowed to do anymore. So I think it's promising. Yeah?
One more for you, Rijn. Can you guarantee that synthetic data is no longer PII?
Now, that's an interesting one. If you Google that, then you see that in general, when you apply the technique well, and they do, I assume, I'm pretty sure, then you can guarantee that it is not privacy information, individual data anymore. There is a risk of overfitting. So probably in your engine, in your process of software development, you have checks to be sure that it is not privacy related information anymore. And that is what you see in the market if you Google that. Yeah.
Do you want to add something, Marijn?
Yeah, exactly. So so basically, indeed, the overfitting part that is something which could occur, which basically means that you want to get as close to your original data as possible, but not closer than that. And that's exactly the kind of the metrics we have integrated into our software to prevent that from happening, so that you get as close as possible, basically. Yeah, yeah.
It's a question, I don't know,
yeah,
but
yeah,
to
sure.
Syntho, from François. Do you have already implemented the use of synthetic data for software testing? Really?
For software testing, yeah, definitely. So, multiple organizations. Yeah, so of course we have the use case, data analytics and AI, but also the software testing, where you want to develop your software, test your software, test for edge cases, and this is exactly a use case that we're focusing on as well. And for instance, there you potentially want to test entire databases, so where you preserve also the referential integrity, so between tables within your database. And that's something also we provide. So, yeah, definitely, we have some customers who also, where we also helping them in that way. Yeah.
Now we have a few questions from Manel. I'm firing them away to you. Any insights on why the relative ranking of algorithm is not maintained?
The relative ranking of... I think those were the results of Edwin that he showed. I think, so there's always...
There's also a variability. The data is not exactly the same.
Yeah.
It's probably the case.
So the data indeed is not exactly the same. So indeed, you always have a small margin of error. Yeah, and that I think can make it 1 or 2% difference in the plot we showed. I think I think that explains it. Yeah.
What are the privacy protection measures you take?
Yeah. So I think we just shortly touched upon that. So so those are basically metrics to prevent overfitting. Well, and basically what we do, we look at some kind of distance measures. Where we look at the synthetic data and see how close it is to the original data, and basically test that it doesn't get too close. And there again, I don't want to get too much into the details, but there again we also used a holdout set, such as Edwin was also using in his setup to really do this in a fair way. So that's basically we use distance-based metrics. Yeah.
Okay. Probably for Rijn, is it synthetic data the future of data sharing?
Well, who knows? I think what I've seen from the test we did, but also, for instance, what the Gartner Group is saying, Analyst Bureau, they predict that in 2024, 60% of data being used to develop AI and analytic solutions will be based on synthetic data. So I think it's kind of a bright future here to use it. And also from the data sharing perspective, you need to collaborate on data normally in big projects. And with synthetic data, I think it's more easy because you do not have all that legal implications, data security implications, etc. So I think it could be a bright future actually. Yeah.
Okay. Back to Edwin, I guess.
Go down to the left.
Synthetic data also tested with and compared with unsupervised learning techniques, scenarios like principal component analysis?
Yeah, in this case, we didn't. There's a lot of additional investigation we can do. We decided to scope this to, well, just build some predictive models, in this case, churn models, supervised learning. But indeed, we can also do a lot of other techniques and try and to see what kind of output, and will be the results be the same. But we didn't do these kind of things in this test.
Okay, well, almost there from the questions. So this final one is from Jeroen. With Netflix unintentionally showing an existing phone number, what is the risk that real data is synthesized? Who's going to take that one?
Sorry,
Could you rephrase it a little bit?
What is the risk that real data is synthesized?
What is the risk?
Yeah, okay, so I think that's the point of overfitting, basically. So that I just mentioned, like overfitting is basically that you're reproducing data points of your original data. And that's basically what we prevent with those measures that we just had a question on. So that risk we basically erase. So that's not possible, so to say.
So there is a blinking smiley with this question. So probably it was
yeah, exactly. Yeah. No, but it's a good question. But that's indeed like the overfitting metrics we
That's all? All the questions are asked? Yeah. Okay, perfect. That brings us at the end of this session. So it only leaves me with thanking Syntho, thanking Wim Kees Jansen and Marijn Vonk for their attendance, and of course enlightening us with all the power of synthetic data and what it can do for us. And then of course Edwin van Une and Rijn Mertens, thank you for being here. Thank you for playing with synthetic data. And of course both of you, thanks for sharing your profound expertise on all levels of data and analytics. And then of course to you and to all my guests here, thank you for your attendance and your attention. And next time when you're facing some legal issues with your data, think about synthetic data and think about Syntho. If you want to stay up to date on everything that we do in the SAS DNA Lab, you can check our website. Edwin, I think you're going to post the website on our chat so everybody can access the website. And that leaves me with wishing you an extremely pleasant evening. Thank you for tuning in and see you next time. Bye-bye.